Aloha, what comes to mind when you hear the term artificial intelligence? Most people think of cutting-edge computer science, sleek robotics, or engineering marvels. But what if I told you that artificial intelligence owes a profound debt to psychology? These two fields are more than passing acquaintances, they're symbiotic partners in a fascinating story of mutual inspiration. From the earliest days of artificial intelligence, psychologists and neuroscientists played a pivotal role in shaping its trajectory. By studying how humans think, learn, and adapt, they provided the blueprints for machines to mimic human intelligence. Concepts like neural pathways, reinforcement learning, and even problem-solving strategies in artificial intelligence were all born from insights into the human mind. Meanwhile, artificial intelligence, in turn, has fueled breakthroughs in psychology, offering new tools to study cognition, behavior, and even ethical dilemmas like bias, echo chambers, and the misuse of AI tools, such as ChatGPT. Consider some of artificial intelligence's biggest schools of thought: the connectionist, symbolic, and analogist approaches. Each draws heavily from psychological research. Take reinforcement learning, for instance. This cornerstone of artificial intelligence was inspired by behavioral psychology, particularly the work of pioneers like Dr. Skinner, who explored how associations, rewards, and punishments shape learning. Similarly, artificial intelligence researchers have borrowed from the idea of Swiss developmental psychologist Piaget, which shows that children learn best through exploration. The result? The rise of unsupervised learning systems that thrive on discovery. You might be surprised to learn that many artificial intelligence pioneers were psychologists. Frank Rosenblatt, for example, was a Cornell psychologist who developed the Perceptron, one of AI's earliest neural networks. His goal wasn't to create intelligent machines but to better understand how humans learn. Rosenblatt's perceptron is just a basic one-neuron and one-layer classifier for one simple function, separating two classes by a linear discriminant function. Specifically, the activation function in this system produces a binary output, 1 or 0, depending on whether the weighted sum of the inputs exceeds a certain threshold. The machine learning rule is a simple algorithm that updates the weights. It sounds complicated. Let's try a simple example. Just imagine you're teaching a very simple robot to be a bouncer at a club. This robot is the perceptron. The bouncer's job is to make a basic yes, no decision: should a person be allowed into the club or not? Here's how our robot bouncer works. Just like a real bouncer, it looks at different features of each person: how formal their clothes are, on a scale of 1 to 10. How polite they are, on a scale of 1 to 10. How many people are already inside, on a scale of 1 to 10. Our robot bouncer has different weights, importance levels, for each feature. Let's say the weight of clothes score is 300%, because appearance matters a lot at this club. The weight of politeness score is 200%, because nobody likes rude customers, and the weight of crowd level is 100%, it's less important. The robot adds all these weighted scores together. Let's say it has a threshold of 40 points. If someone scores above 40, they get in. If not, sorry, better luck next time. However, the perception is not pre-programmed in the sense of regular computing. Rather, weight modification in the perceptron depends on performance evaluation by an external agent. In today's terminology, it is a form of supervised learning. Utilizing an IBM 704 mainframe computer, the state-of-the-art computing machine in the 1950s, Rosenblatt used the preceding approach to distinguish the card marked with a square on the right and the other marked on the left. After 50 iterations, the electronic system learned how to perceive the information and make the correct decision. Interestingly, the prototype of machine learning was pioneered by a psychologist rather than an engineer. Despite the significant contributions psychologists have made to the development of AI, many researchers in psychology today remain reluctant to adopt machine learning methodologies. Fast forward to today, artificial intelligence systems now feature countless artificial neurons and layers, far more sophisticated than Rosenblatt's single-layer perceptron. Yet the principles he worked on, trial, error, and adjustment, remain fundamental. It's a reminder that every futuristic breakthrough has its roots in human curiosity and age-old questions about how we think and learn. Artificial intelligence and psychology don't just coexist, they fuel each other, opening new doors in both fields. From mimicking thought to tackling modern ethical dilemmas, their partnership is a testament to the power of cross-disciplinary innovation. Notably, Geoffrey Hinton, the 2024 Nobel Prize winner in physics for his groundbreaking contributions to neural network development, bridges two worlds as both a cognitive psychologist and a computer scientist. So, next time you hear artificial intelligence, don't just think machines, think minds.